All right, Chem 107. In this video, I'm going to talk about molecular polarity. So you've watched the video, I assume on bond polarity. Now we got to talk about what happens in an individual molecule. So let me just draw a simple case here. So here is CO2. Okay, and if we look at this molecule, we have what we call a dipole moment. In other words, we have a partial negative on this oxygen, partial positive on this carbon, partial negative on this oxygen. So what that ends up meaning is the electrons are being pulled in this direction, away from the carbon towards the oxygen, and that's simply because oxygen has a higher electronegativity. And then same thing happens in this direction. So this becomes a tug of war where we're pulling the electrons away from the carbon towards one oxygen and towards the other oxygen. Now let me ask you a stupid question. Which one has higher electronegativity? The oxygen or the oxygen? Well, they're the same. So what ends up happening is they cancel each other out, and this becomes a non-polar molecule. Because they pull in opposite directions equally, it's a non-polar molecule. So we could do the same thing with a slightly different molecule. Let's look at methane. I'm sorry, not methane. Carbon tetrachloride, CCl4. A Cl bond, a carbon-chlorine bond, is a little polar. So what ends up happening is that all the electrons are pulled towards the chlorine. Okay, and they're pulled in this direction. But because this is a symmetrical molecule, again, they're pulled in the same direction, or I'm sorry, they're pulled in opposite directions equally, so this too becomes a non-polar molecule. Okay, so to sum up non-polar molecules, if there are no polar bonds, or the molecule is symmetrical. Oops. No, how do I? There we go. Symmetrical. If the molecule is symmetrical, then it is a non-polar molecule. So remember that. No polar bonds or the molecule is symmetrical, then it is a non-polar molecule. Okay? For a polar molecule, let's look at a polar molecule really quickly. Something like SO2. Now if we look here, the electrons are being pulled in this direction and in this direction with nothing to oppose them up here. Okay? There's no other oxygen to oppose them. So this would be a polar molecule. And remember, polar just means it's like the North Pole, South Pole. Those are opposite ends. So we have a molecule with a little positive and a little negative. Okay? And to get a polar molecule, you have to have two things be true. The molecule has to have polar bonds. And the molecule, let me erase that. And before it was or, now it's and it must be asymmetrical. Asymmetrical. That is non-symmetrical. So just one more example. Again, a molecule that you see every single day and never think twice about it. So in this molecule, the oxygen pulls the electrons this way, and so what ends up happening is we get a net pull in that direction. If you remember trigonometry, if not, don't worry about it, but that is indeed a polar molecule. It has a polar bond. Oxygen-hydrogen bond is polar. We can even label it partial positive, partial negative, not an 8, partial negative, and partial positive down here, okay? And it is asymmetrical. There's not 4 hydrogens on there, which would make it symmetrical. Okay, that's it.